Namaskar friends, welcome to Electronics Technology YouTube channel. Topic of electronics technology news is better 3D printing for accurate and reliable tissues. Tired of 3D prints going wrong? Learn about a system that catches mistakes, saves materials, and makes tissue printing more reliable. The monitoring platform is composed of a digital microscope housed within a custom 3D printed support. 3D bioprinting enables the creation of complex tissue structures, but accuracy and consistency remain a challenge. Traditional methods deposit cell-laden bioinks layer by layer into a support bath. While these approaches can build 3D structures, they make it difficult to detect and correct defects, such as over or under deposition, in real time. This results in variability in tissue quality and limits reproducibility. A major limitation of current 3D bioprinting is the lack of integrated process control to reduce defects, which could also improve resource efficiency by minimizing material waste. With so many bioprinting tools available, there is a clear need for modular, efficient, and accessible process optimization methods. To address this, researchers at MIT developed a low-cost, modular monitoring system for 3D bioprinting. The system uses a compact digital microscope to capture high-resolution images of the tissue during printing. An AI-based analysis compares the images to the intended design, allowing rapid identification of print defects. The system works independently of the printer and supports layer-by-layer imaging, helping determine optimal print parameters for different materials. The monitoring approach is scalable and adaptable for standard 3D bioprinters and has already been integrated into bioprinting facilities. It not only serves as a real-time monitoring tool but also lays the groundwork for process control in embedded bioprinting. By enabling inspection, adaptive corrections, and automated parameter tuning, the system helps reduce errors during printing and improves the reproducibility of tissue structures. This method supports reproducibility, sustainability, and automation in tissue engineering. It reduces material waste, accelerates process optimization, and provides a consistent framework for building complex tissues. By improving quality control, the system ensures that fabricated tissues are more reliable for both research and therapeutic applications. Do you like this video? Please subscribe, share, like, and press bell icon for getting notifications of Electronics Technology YouTube channel, and for searching my YouTube channel please write at the rate Electronics Technology 50.